All right, guys, so hopefully I know the last time I did a smartboard recording, it didn't work out too well, and some of it was cut off, but hopefully this time it will work correctly. These are going to be our parallel proofs, our parallel line proofs examples. We're either going to be proving something about angles, or we're going to be proving that lines are parallel. So to start off with, we're going to go ahead and look at what we have at the very, very beginning here. And we're seeing here our given tells us that angle A and angle B are parallel. So I'm going to go over here and make sure that I mark A and B parallel. It tells us that line A and B, line L and M are also parallel. So I'm going to mark these parallel, but the problem is I can't just leave one arrow each, because then it means all four of them are parallel. So I have to add in an extra little arrow to say L and M are parallel to each other, but not to A and B. So when we look at our two-column proofs, the first one is always going to be our given, okay? And then we look down at, say, an angle 12, and angle 12 is congruent to angle 13. So what we're going to do is we're going to go find angle 12 and angle 13. Let's take a look at those. When we look at them, how do we know that those are congruent? Well, we can take a look at our different angle pairs that we have learned about, and we see that they are both on the same side of transversal. 13 would be interior, 14 would be exterior. So I know in my class I've taught that if we find ourselves saying, are they inside or outside? We say both. We need to ask ourselves, do they match? Are they in matching positions? And 13 is basically on your bottom right, and so is 14 on the bottom right here. Okay, so we could say they are in matching positions, matching meaning corresponding. So this is going to give you your corresponding angles postulate. We'll just put corresponding angles post. Okay. Now we're going to take a look. It says that angle 13 and angle 1 are congruent. So let's go find angle 13 and angle 1. And we notice that they are going to have a relationship here. We see that they are going to be on alternate sides of our transversal B, and they are exterior from our parallel lines here where we have our little car drawn. There, so we're going to have alternate exterior angles. So we can just say this is our alternate exterior angles theorem. And we're going to abbreviate that. Next, we're talking about angle 12 being congruent to angle 1. So when we take a look at angle 12 and angle 1, right here, angle 12 and angle 1, we're going to notice that they have absolutely no relationship. They don't have a transversal, they don't share a line. So we can't be on alternate or same sides of the transversal because there is no transversal. So we can note here that we have no relationship. And so then we need to go ahead and we need to take a look at what's going on up here above it so we can figure out how do we know that angle 12 and angle 1 are going to be congruent. And we see here, we could cut out the middle man right here, bring an angle 12 here and angle 1 here. And cutting out that middle man is our transitive property. Just put transitive prop. And the last thing that we see here is now we're saying we're proving that angle 1 and angle 12 are congruent, which we already have here, but we need to look at what has changed between these last two, and what we've noticed is we've switched. So when we switch, we go back to our old notes, and we know switch is symmetric property. Okay? So a little rundown on short two-proof column. We'll go ahead and move to our next one right here. And we'll start off reading our given, saying that line A and B are parallel. And line L and M are parallel to each other, remembering to put our parallel marks. And we have 2 on line L and M. So our first one, as always, is going to be given. And then we're going to take a look at angle 16 and angle 11. So here's 16 and here's 11. And we notice here that we are going to have, we're on the same side of transversal, M, but one is interior and one is exterior. of the little road right here, which I'm probably going to erase this a little bit. One is inside, one is outside. So we need to ask ourselves that third question, do they match? Are they in matching positions? And angle 16 is in the bottom left, and angle 11 is also in the bottom left. So we are in matching corresponding positions, giving us our corresponding angles postulate. So then we're going to take a look at angle 11 and angle 6. So back to angle 11, this time we're looking at angle 6. We notice that they do share a line in common, which is your transversal. It's cutting through two lines at different points. Our transversal is going to be line A. We are on alternate sides of the transversal, and we are, I guess we can do my car in a different color. It is just getting better. We are on the exterior of the road, or the parallel lines. So here between angle 11 and angle 6, we have our alternate exterior angles theorem. And then our last one is talking about angle 16 and angle 6. So we look at angle 16 and angle 6. And again, we're left with no relationship. They do not share a line in common. They do not share a transversal. So we once again have this no relationship. And when we have no relationship, we need to go ahead and look up and see what's going on with some of the statements above. And if we look, we notice here again, we've got to cut out the middle man right here, leaving our angle 16 and our angle 6 congruent with each other. And when we cut out the middle man, we have our transitive property. Okay. On the other side, we're going to take a look at some pretty lengthy ones, but you're going to have these. The first one are given is angle 1 and angle 3 are supplementary. There's really not much in our picture that we can draw, okay? There's not a lot we can write or label, because all we're given is that they're supplementary. So our first one here, as always, will be our given. Okay, so follow along with me here. Whenever we go from two angles are supplementary to two angles add to equal 180 degrees, I know I discussed in my class, a lot of times our definitions are going to have these degree measurements. So when we have two angles that are supplementary and therefore their measurements add to equal 180 degrees, this is just going to be our definition of supplementary angles. Okay, we're saying that they're supplementary, and if they're supplementary, then their measurements add to equal 180 degrees. When we move down to angle 2 and angle 3, our vertical angles, okay, we look up here and we see angle 2 and angle 3 right here, okay? We could say this is the definition of vertical angles. Now the difference between the definition of vertical angles and the vertical angles theorem is going to be, even though we're looking in the picture to see that they are vertical angles, we actually have the words vertical angles written out, because your definition states that their location, being across the vertex, they're vertical angles. And then once we move on to the vertical angles theorem, that's when we're actually saying the angles are congruent. So here I'm saying angle 2 and angle 3 are congruent. How do I know? Because of the vertical angles theorem. So your definition actually will have, if I say the definition of vertical angles, I actually have the words written, vertical angles. But if I tell you that the two angles are congruent and you look in the picture and you see that they're across the vertex from each other, and it's saying it's congruent, that's what your vertical angles theorem is saying. If two angles are vertical, then they are congruent. Okay, it's the difference between those two. Next, we're going to move down to the measurement of, I'm going to use blue, get red. The measurement of angle 2 is equal to the measurement of angle 3. This is going way back to when we first started doing proofs. If two angles are congruent, then their measurements are the same. I will repeat, if two angles are congruent, then their measurements are equal. This is your your simple, plain definition of congruent angles. We go back to that. If two angles are congruent, then their measurements are the same. Okay? Next, we're going to look at measurement of angle 1 plus the measurement of angle 2 equals 180 degrees. What we need to do is we're going to have to go all the way back up and look at this other equation we have. A measurement of angle 1 plus the measurement of angle 3 equals 180 degrees. What I want you to notice, the difference between these two, sorry, I actually did the wrong one here. Let me go back and fix that. There we go, looks better. The difference between these right here is going to be, we have changed the measurement of angle 3 in the equation to measurement of angle 2. So we have done what we call replace. We have replaced the measurement of angle 3 right here with the measurement of angle 2. We were allowed to do this because of this statement right here, saying anywhere that I have the measurement of angle 3, I can replace it with the measurement of angle 2 because they're the same. So we have removed the measurement of angle 3, and we have replaced it with another measurement angle that is equal. Okay? So that replace tells us our substitution. Substitution. Okay? So we have our substitution property. Now we're going to take a step down, and we are going to take a look at what is going on right here when it says angle 1 and angle 2 are supplementary angles. So we have actually already seen this in this proof. It was just the other way around. Remember that we can reverse these. We earlier said that the angle 1 and angle 3 were supplementary. Therefore, the measurement of angle 1 plus the measurement of angle 3 equaled 180 degrees. Now we're going the other way around. We're saying the measurement of angle 1 plus the measurement of angle 2 equals 180 degrees. Therefore, angle 1 and angle 2 are supplementary. It's the same. It's going to be the exact same definition of supplementary angles. And so we look up here and we take a look. We take a look at those two angles, angle 1 and angle 2. We need to prove, we have one last thing to say here, and we're proving that these two lines, L and M, are parallel. So we need to take a look above it and see what two angles are we talking about. And we're talking about angle 1 and angle 2 being supplementary. So when we come up here and we circle angle 1 and 2, we need to figure out what is our relationship between the two of those angles. And we notice that it is on the same side of our transversal, and they are interior of our road. Really bad car. So we're on the same side, and we're interior. So we're going to have our same side interior angle theorem, but because we are proving parallel lines, all right, I know in my class we wrote proving parallel lines above the section, okay? Oh, I keep doing that. Come on. Okay, so proving parallel lines, we are dealing with a converse. Okay, so we're dealing with the converse of same side interior angles theorem. And I know that in my class I stressed that with the other notes, that if we are proving parallel lines, we are going to be dealing with the converse, because the converse states that if we have two lines cut by a transversal forming two same side interior angles that are supplementary, then we have parallel lines. All right, so the last one here, let's see if my marker can hang out just a little bit longer and do what I ask it to. All right. So we have a weird looking picture here, but we're going to walk through little by little and see what's going on. We're given that angle 4 is congruent to angle 7. So right here, angle 4 and angle 7 are congruent. So I'm going to go ahead and mark that. We're also given that angle 5 and angle 6 are congruent. So I have 5 and I have 6 that are congruent. So first step, first statement here, angle 4 is congruent to angle 7 is a given. It's given to us. Now what changes here is we're not going straight to the next given. Now we're told that angle 4 and angle 5 are congruent. And how would we know that angle 4 and angle 5 are congruent? Because we have discussed this in class, angle 4 and angle 5 are vertical angles, giving us our vertical angles theorem. We're told that the two angles are congruent, so we look up in the picture and we see, oh, they're vertical angles, so it has to be our vertical angles theorem. Now what we're going to do is we're going to go down to angle 5 is congruent to angle 7. So we're looking at 5 and 7 right here, okay, right here and here. We do not have a relationship between the two of them, okay, so between these there's no relationship. So therefore, we need to take a look on what's going on above it to figure out what happened, okay? So the first thing we have here is we have the first one we stated, angle 4 is congruent to angle 7. I want you to notice that angle 7 is still there, but angle 4 is no longer there. Angle 4 has been replaced with angle 5. And we can replace that because of this statement right here. Okay, so since we have replaced, we have the substitution property. Okay, so notice that 7 is still there, angle 7, but now we have replaced angle 4 with angle 5 because we know they are congruent as well. The next step down, we're looking at angle 5 is congruent to angle 6, right there. Angle 5 is congruent to angle 6, so this is another one of our givens. Then we look at angle 6 is congruent to angle 7, okay? So we look at angle 6, and we look at angle 7, and what's actually happening here is we can look at this as a couple different ways. We can look at this as another substitution, because we're saying here that the, I'm going to get a different color lighter. Actually, I need my pen first, sorry. So let me find the color, it's orange. If we look up here, we have the 7 being carried down again. So 7 keeps being carried down, but this time, this will give a different color highlighter. We see that angle 6 has been replaced with angle 5. And we know that we're allowed to do that because of this statement right here. Angle 5 and angle 6 are exactly the same measurement. They're congruent, so we're able to substitute again, giving us another substitution property. Now, when we are proving that lines are parallel, this is where we want to go back up to the previous two angles and look at. This is why I did not go circle the two angles and say, oh, these are the kind of angles. That's why we have the substitution here instead of the angle pair. Because these are an angle pair, but we're having to prove parallel lines, so we want to save that. So when you see that the very, very last one's proving parallel lines, and you see that, oh, this is an angle pair, we don't want to write that in just yet. We want to wait to the very, very end. So when we look at angle 6 and angle 7, angle 6 and angle 7, change colors over here so you have red up here. We look at angle 6 and we look at angle 7. We notice they are an angle pair. Here is their transversal, okay? And because these two are congruent, we have alternate sides of the transversal, and we are interior to our road. But because we are proving the parallel lines, we do have to do the converse. So the converse of whatever angles these are, and as we discussed, they're on alternate sides of this transversal, so we have alternate, and they are on the interior. Okay, so we have alternate in the converse of alternate interior angles here. Okay, I know that was a little tricky, it was very lengthy, but you're going to see pictures like that. Okay, and that concludes